Hey everybody, we're going to spin up a quick test environment for KMCoin on Minecraft. So first thing you're going to do is GitHub tin hat cat. Close enough, I suppose. Go to the code, download the zip, navigate to your downloads directory, extract the file. Once that is done, we will go ahead and navigate through two directories created by GitHub to get to KMCoin win. We need to move this to the Minecraft uh, logs folder so it may retrieve the latest log from the player. So let's copy that one in here, scroll back up, there it is. Let's go and enter that folder. Close that one out, no big deal. We also may close that. Bring Minecraft up and go ahead and compile and execute this program. Notice they're all Java files, easy for inspection. We did not pack it into a jar. So go ahead and execute a command prompt from this directory so you may compile the Java files. javac *java, it just creates the class files in the folder. And then we are going to execute java kmcoin.java because that is the Java file that contains the main argument. Put in your player name as it's listed in the server. Input a private key that is different from your Minecraft name. Write it down, make it complex. You will own it. We'll go ahead and do a little sync with chain tutorial. Even though we're spinning up a new world, we can still talk about this. I should not have executed it immediately. So let's go ahead and do this one more time. CMD, Java, we've already compiled it, so just java kmcoin.java. Sorry, puppy, I hear you back there. So yeah, execute that command, and we will do this again. Player name, password, private key, sync with chain. Now, wait, we will read this. If this is your first login, mine a block before syncing. Sure. Go ahead and select mining only for your initial block. I recommend that. Log into the Minecraft server. You'll wait for a block to be mined. And what that will do is all of the ledger files that are necessary for syncing are updated at block time. So all of those files will not be changed until the next block. Therefore, when a block is mined, you may source the files, and once you have put them in ledger KMC and replaced ledger current player info and ledger hashes, you may hit enter on command prompt, and it will populate the transaction panel and also tell you that you claim to be this person. Welcome to the kitty mine. Players must mine a block to obtain a wallet address and then placed on player info. So let's go ahead and open player info here. We see it's blank. No one's mined a block. We can refresh the transaction panel. We have no information. So now that it's running, let's go ahead and oh yeah, create a new one. I did that one earlier. We're going to do creative so we can execute server commands, and go ahead and put it on peaceful unless you want to deal with mobs. And let's go ahead and create a new world. Now it is vanilla. We do need to put the data packs in. So let's go back, edit, open world folder, navigate to data packs, and then go to data packs in the KMCoin win folder. They're placed there for development. Copy and paste them over to the Minecraft folder. Go ahead and close that. And then we can go ahead and enter the world. Now, to activate the hash pack, a player must leave. You will enter the overworld on your first login, and if you try to do a command, it will tell you hold poisonous potatoes, and if you try to do a try hash, it will tell you must leave and rejoin the server to activate the hash pack. So let's do that. Now it's going to register that we have left the game, increment our scores, and put us in the lobby. I think I know what I'm doing. Yeah, and here it is. Very simple. All of the potatoes spawn every minute, which is block time. It was designed that way. And also, when a player comes in the server and they have not tried a hash, they get one free one. Trigger try hash. Now we are teleporting in the hash zone to kill any bees that are present from the previous attempt. Now we are teleporting in a 2x2x2 area, and those coordinates are summed up to and compared to simply odd or even. The program will automatically choose odd if the player doesn't make a selection. And in that case, the hash was even, and we did not get it. So let's do a little in-game work to farm up a hash try. In the server, it's all listed on KMCoin.com, the crafting tables, but you may. Sorry, I split it like this. You need 9 baked potatoes to. Goodness, I know there's a better way to do this, everyone. 9, we can use this to get the poison potato, trigger get hash. Now, let's go ahead and do scoreboard objectives set display sidebar hash timer. And now we will do a scoreboard set objective set display list try hash. So, I'm sorry, scoreboard hash try. Now we see we have 1 hash try score for the poison potato that we traded. Now let's go ahead and try that hash. Again, killing any previous bees, you could see them dissolve right there. We are in the small area with the very simple odd or even hash mechanism. We got lucky that time, and we are now creating the random string block information through the coordinates of the player as they're teleported through this 10 by 10 by 10 area. Then they are teleported to the hash zone, where they put all of the information from the hash on signs for viewing later. But before we get to that, let's talk about this information. What is this hash and how is it computed? This hash is computed by SHA-256 2002 times of the first block mined by the player, which you see here, plus their private key. And the reason we've done it 2002 times is we use that structure to validate transactions. And now that I've mined a block, let's go ahead and refresh this, and we see that I've got a wallet and I have a balance. And if we look at player info page again in Ledger KMC, we see that I've been populated with this particular hash. This becomes my public key. And in order to do transactions, the player just simply select an amount. The receiving wallet will be, again, the first block a player mines in the server becomes their wallet. So I have wallet 1 forever. If somebody wants to send me coins, they would put 1 in here. But I'm going to go ahead and put a different number. There are no other players to receive it, but it will be deducted from my wallet as if it were burned. If wallet 2 was present on player info, their information would be populated as well. So now that we've mined a block, let's go ahead and generate a transaction here and copy it and pop it into the server. Notice it sees that we have someone has input a hash, and the transaction hash is actually the SHA-256 2001 times. And that's what we use to build the transactions. Once you take the hash of this transaction hash right here, it will create the public key. Now, this actually verifies here. It calculated this hash and it matches the public key. So since that is true, it will add that line to latest transactions 4. And this is where all of the transactions between block are housed. And let's go ahead and do one with more gas. We'll do 10. Generate a transaction. Notice the private key changed, or the transaction hash changed. We have revealed the previous hash to the public key to the entire server. So the transaction is incremented when everyone in the server sees that they have provided the correct transaction hash. And if we go to player info page here, we can see that that has been changed. We've done one transaction, it's pending, we're not sure if it's going to work, but once we put this one in, we will then verify the next hash. It found it. The transaction hash is this, and if you were to do SHA-256 twice, you would indeed get that public key. And that is how we verify this. Player info page now shows 2 transactions. We'll leave that up and go ahead and mine another block and see how that changes everything. oh, let's look at ledger current real quick. The block, the player, their public key, and then the consensus hash. Very simple. Now let's put some transactions in here and see what that looks like. Oh yeah, we got to do some more work to get a hash try. We don't have any. We'll try it real quick. Trigger try hash. Still not working. So let's go ahead and farm up a little bit, and we will craft a poison potato. Oh, we got one. Yes, there's a 1 in 50 chance when you break a potato plant that you will get this. So trigger get hash. Now we have one try. Trigger try hash. Let's do this. Let's see what happens. So again, generating the random hash, odd or even, we got it. Now it's making the long string of random numbers through the teleportation. And yeah, once this is complete, we will see the transactions have been removed from latest transactions 4 and applied to the ledger. So real quick, let's check out player info page again. Yeah, see the 2 transactions are there. The balance has been changed, and all of that was burned because no one's here to receive it. So now let's take a look at ledger current, where we can see after the last consensus hash that we just saw, we have the next block, the player name, their hash, and then the transactions we input in order of optional gas. Or I'm sorry, minimum 1 gas, but it's ordered by gas, and that's this value right here. It is programmed currently to take the top 100 transactions in gas. Can easily be augmented to take more. It's just a simple variable. But it was simple. It was something easy to work with, and I thought it would be sufficient for now. So you see the transaction structure. You see how it's appended to the ledger. Let's talk about how it's validated real quick. The way that we were able to keep this robust and small and fast is once ledger current reaches 100 megabytes, it is SHA-256 twice, and then that hash is appended to ledger hashes. And then that file is copied to the first directory in KMC1, and then ledger current is cleared. So what this does is when you take the hash of ledger current, and then you take the hash of player info, and then you take the hash of ledger hashes, and then you take all of those strings, put them together, and hash it again, you then get the consensus hash. So we created a way to pack away the ledger, keep the information intact by hashing it, while also keeping the sync time very, very small, allowing players to only have to download, 64 characters per 200 megabytes of ledger size. And, the current ledger, which at max will be 100 megabytes, and then player info page at a million players would be somewhere between 100 and 200 megabytes, giving us a max download size of around 400 megabytes, when this is built up really, really big. Currently, the download size is, extremely small, so players can sync in seconds. And again, we talked about moving the files in after a block is hashed, triggering the command prompt, and syncing up with the chain. So again, how does one verify transactions in a public setting like this? And this was the solution that we developed. We use the first block mined only, so that players don't have to retrieve a string from an unforeseeable long bit of information. Let me make sure I'm covering everything. There's something I'm missing here. Oh yeah, the main point, or the barrier that you're probably looking at now, is we only have 2001 verifications in front of the public key. What do we do about that? Well, if you notice these values that say null, they will only be populated on the 1000th transaction of the player. And what happens here is once this transaction hash is verified by the rest of the players on the 1000th TX, this null field and this null field will be populated with 2 other hashes. So once this is verified, players will automatically read the final hash because it is the player's new public key, and it's simply calculated as the player's first block, their private key, plus a 1, just a little bit of nonce. And we'll do that for the first batch of transactions. And then on the 2000th transaction, the same thing will happen, and it will simply add a 2, create a new public key, everyone will append it to player info, and we can run this forever. If anybody has any questions, please feel free to reach out to me, and we'll help you work on it. Oh, last thing, navigate to your data pack folder, and I will show you real quick how to get to the lobby to adjust it. So if we look at the lobby here, we see a very basic, square. If you jump off the edge, you'll be teleported back to the pond. You're forgiven. You'll keep your stuff. No big deal. Respawn. I need to set game rule. Automatic or do immediate respawn. My apologies. Be sure you set these parameters. Do immediate respawn. Game rule. Keep inventory. And then game rule forgive. I'm sorry. Oh, game rule. Sorry. Game rule. Forgive dead players. And now let's go ahead and come back and jump off the edge again and see if it works. And then we'll talk about the structure of the lobby and how you may augment it. So I think I know what I'm doing. We're back. Let's jump off. It took all my stuff, dang. But hopefully we will be teleported back to the right location. Do immediate respawn, please. Single player, new world. I know what I'm doing. We're back. Game rule. Do immediate oh. True, everyone. Go back. Keep inventory true. Forgive dead players true. I should have mentioned that in the beginning. My apologies. Now, let's try this again. Jumping off the edge. We're not going to go to the overworld. It's going to take us right back to the lobby. And there we are. Wonderful. Don't forget to put true after your in-game Minecraft rule commands. So after suffering through that, let me go ahead and explain to you how to work on this lobby data pack. This is the tick function. It will read this every tick. There are 20 ticks in a Minecraft second. So we see the light blocks that are in place just to keep it lit up so it doesn't get dark. The crop timer sets the potato plants. Here is the structure. I'd simply put a bit of air to stop people from, getting out of the lobby. I don't know if it was sufficient, but here we can see the water, the grass, all this stuff. You can augment the structure, put any proof of work mechanism you want in there that produces an item, that we could trade for poison potatoes. Again, poison potatoes are uncraftable in the game. You can only get them by farming, and with the custom craft tables, you can use the work in game to generate those easier. But that's the lobby, and the last thing I'll show you is the hash pack. So the main driving part of the hash pack is the add block. And we can see here tons of lines of code, but what we did here was ensure if a player left at any point in the process, it would simply just be a failed attempt. It would go to the next player, they'd get their attempt, no big deal. There's no way in the server during the process to I guess you could say affect the block number in a negative way. It has been timed so that everything happens instantly at block time, and if a player does anything before that instant, it just does not occur. But yes, looking at all of this, I put some parameters in here to stop people from moving around, so they would put their hash on the right sign. In fact, if you move around too much, you will have a failed attempt and be teleported back to the lobby. So we can see here, this is where the UUID is calculated and all of the other information. Here it sets the text on the signs on the blockchain, as well as right here. We can look to see our information. There's my UUID, the game time, the solution that the odd solution that produced the correct hash, and this was the random string of numbers that was generated by the B teleportation. Let's verify real quick that we see this on. Oh yeah, I need to back out of here a little bit. Let's verify we see this on the ledger current real quick. So we're looking for 2881 dot dot dot. There it is. And now if we navigate to this side, we can see that was the first one, had no solution. So this should be the next one. And also the previous one is put on as well. So 17466, let's verify. There we go. 17466, that's the odd solution. And let's verify that. There it is. And all of the coordinates in the first B teleportation stage are present here. So you may see the coordinates, see how they're added, and verify that it is true. I think that covers the bulk of what you need to develop a, you know, what you need to develop KMCoin in a closed setting where you can test, try things, and develop. I hope this tutorial served you well. And again, the Kittymon loves you. Thank you all so much.